Right, here we are. We're live with MOOCamp. This is Sam trying to prep the old week one materials and deal with other bugs and issues in the course. Um, so I'm just turning off Skype to get rid of the distractions. Just looking at this quiz names mismatch issue. I guess I don't. I'm not sure what the solution is there. I guess what I really need to do is kind of get on. I don't know. I've got two background issues. I've got one request from an instructor about missing subtitles in one part of the course. I guess, and I think there was also we had an issue with now what was it? I can't remember. This in the Stack Exchange, there was something. This is missing, or the transcripts being wrong. Not this one. Um, the, oh, so I'm looking now for something that somebody reported. I guess I had emailed Elena about it at edX. So if I can search for emails that I've sent her. Okay, wrong download links. This is the question. Right, and I was having trouble editing anyway. Ugh. And here I agonize. I'm not sure. Should I should be working out the week one things, or should I be fixing these issues? Anyway, so I mean, I have to go back in here. I had the course outline there. Anyway, I was checking that quiz issue had been fixed. That quiz issue had been fixed. What we'll do now, we'll get this one out the way. So this is it says video 2, video 3, ESaaS chapter 3.4. That's here. This is, right, which has got a number of different videos. Okay, so let's get out. It's video, and it's referring to them as 1, 2, and 3, like that. So we've got video 1 there saying, so it's video 2 here that we're trying. The correct links should be, so in advanced here, and the thing was here, what was Alina saying that I had to do here? Alina was saying, use the clear arrow and then add the appropriate link in the video sources section below. Okay. So I now have to, is that the, did I update the transcript? The correct link should be, I updated the transcript. I couldn't update the video download. Let's grab the correct video download. That, for some reason, that's clear. And then video sources add. Does that mean I've now added it? I don't know. Video sources add. Okay. Save. Okay. So now the download video, is that the right one? And then that's the transcript that is not matching. Oh, I don't know. Close the draft, edit the draft. The correct link should be that transcript there, S3, that's the duplicate of video 1. No, so the transcript's not updated. Let's edit this again. Advanced. Download transcript. No, that apparently is wrong. Correct. Oh, I've got this wrong there. What? Wait, what? Have I got this wrong? that has to, the SRT file has to be the transcript. Yeah, okay. And it should be that one. And then has this editing window changed since has it got no video sources? Download transcript. What on earth has happened there? And that's the add video sources. I have to hit return there maybe. Save. Okay, so now the download video, that looks right, and okay. Maybe the peer learning question one over here, edit a draft, and advanced. So the transcript should be this SRT one, and clear that download video. And somebody was telling me there's something now about you got a handout, right? Video sources, add. Okay, save. So now the download video should be that S5. Okay, think I have fixed this now. Please confirm. And Stack Overflow just seems like it's a bit of an awful setup for I can't remember what it's called. Bug reporting. Anyway, so that we didn't even have a bug report there. So let's move on from there. Course outline. We're okay. I guess I need to be listening to these, don't I? So we've got this, and what I would be tempted to do here. This is section 2. So the question I have from Wei is that subtitles of the following segments are missing. Let's see. Do we have a transcript for that one? I have a snippet for this second video. Yeah, I don't have a transcript for that. So it's a way. So section 2, and then he's got section 2.6, which I've got to there. Yeah. We don't have those transcripts in the edX dump. I mean, I guess there's then the question of we have transcripts in other places. Right. So there was was there a place that the transcripts were going to? Not seeing so many of the emails was that but anyway, that was Miles Lincoln was the person we were talking about here. But so what was the I mean, I guess Are they just, is it possible to just, like if the video copy link address was here, if we just put .srt on the end, is that how all the other ones were? mp4.srt. Yeah. Yeah, that doesn't seem to exist for that one at least. And for this one, .srt, no. Did they have somehow? There's some way that we got the. Can we list all of the pieces on here? Get it? No, we can't view them. The week 3. Week 3. Week 4. Okay. I guess I need to get in touch with this guy, Miles. We'll say I'll just say, hi Miles, hope you are well, and thanks so much for all your work on the transcripts. We're just running the MOOC again and identified a couple of videos without transcripts. Over here, let's see. Normally we can get transcripts by popping .srt on the end, but not in this case. I don't think I have access to the S3 instance. Can you possibly help me understand how I might ferret these out? Many thanks in advance. Cheers, Sam. Okay. I have emailed the Berkeley person involved in transcripts to check. When you say course package for the second part, you mean you just want an XML data dump of part 2 shared over Dropbox. As before, let me see, did I know I was doing it from, if we look at way, way, I don't know. Just sent in I have sent in the Dropbox before. Have I put it into? Did I set up a GitHub repo for him? Exported file. Okay. Don't know if I put it in. Okay. Right. I see. Currently releasing and revising 169.1x to the world, including updating section headings, section numbering to match the 1.0.1 textbook. Let me know what's the critical priority for you. In 10 weeks, we'll have finished reviewing and revising the entire MOOC, including 169.2 for the latest texts. Okay, so I've responded to him. We've fixed one thing in the MOOC. I'm not going to get into dumping that thing there now. I don't need to care about those. We do need to look at the course outline. I do need to start having this. So we're going to have more Ruby, and then we're going to have this. So what I need to do is get... I've already done that for lecture video. What is that? Oh, I have. Let's go to view live on this other one. So we're going to start listening to Armando on all programming is metaprogramming.
So what do we mean when we say all programming is metaprogramming? What are metaprogramming and reflection? They're $20 words. It should make you feel smarter to use them. But reflection means we can ask an object questions about itself at runtime. We can modify itself at runtime. And metaprogramming means when we write code whose job is to write new code that at runtime actually causes interesting things to happen. So the question is, are these just $20 words to make you feel smarter, or do they play some role in making your code more dry, more concise, or otherwise easier to read? And of course, I wouldn't be explaining it unless there was an affirmative answer to that question. So to illustrate it, let's modify our bank account to make it international. We want to be able to deposit other currencies. So we can already say deposit $100. It'd be nice if we could deposit, let's say, euros. So we could deposit euros to dollars 20, but that's pretty ugly. That looks like something a programmer might write. 20 euros is like a dollar in today's currency or something. Okay, so that's ugly. What else might we do? If we were in a traditional object-oriented language, we might be forced into something like this. Instantiating a currency converted. Yeah, I know, right? Grown with me. That's terrible. So that's not beautiful. We're all about trying to write beautiful code. So what would we like to be able to say? What would be a more readable version of what we want to do? Well, that's dollars. How about that for euros? That's pretty clear what you want to do. And this is no problem in Ruby, because one of the nice things about a dynamic language is that we have open classes. That means that we can modify, not only creating our own classes, but modifying and extending the classes that Ruby ships with. So how would we do this? Well, we already know everything's a method call, right? So if we write this, we're saying that euros must be a method that we can invoke on the receiver 20. That makes it an instance method of the numeric class. No problem. We open the class, we define our euros according to an exchange rate that is what we call the good old days in the United States, and we're done. Does this really work? Well, let's try it. It's okay. I reopened the class. I added a method. Pretty cool. Okay, but before you gasp in further astonishment, let's go further than this. What about that? What about that? This is problematic because our function is called euros, not euro. Well, there's a dry solution to that, but to motivate the solution further, let's try something even more ambitious. Let's go beyond that and say, I also want to support other currencies. But it'd be kind of wasteful if all I'm really dealing with is a list of currency names and conversion factors. I don't really want to write n separate methods that look like my three-line method. So surely there's a dry way to do this. So there is, in fact, a dry way to do this, and here's one possible solution. I've reopened the class numeric just like before, but now I have a more general, here's my hash, which just maps currency names to conversion factors. No surprises there. This is the cool part. One of the facilities in Ruby is called method missing. So method missing gets called when you call a method on the receiver, and the receiver doesn't know any method by that name. But if you define a method called method missing in your class, it will receive a call instead. And method missing is passed up to 3 arguments. The first one is the actual name of the method you tried to call, but which doesn't appear to exist, a list of the arguments that that method would have received if it existed, and optionally a block. We'll learn a lot more about blocks shortly, but because most Ruby methods are written so they can take a block as an argument, there's a possibility that our method could be allowed to as well. So what method missing does in our case is it looks at the method ID, converts it to a string, gets rid of any final s. Remember we have the problem of wanting to be able to call 1.euro as well as 1.euros. So we're basically going to canonicalize the name of a currency to its singular, and then we just ask whether we already have a key for that currency and we convert it. Minds are slowly being blown. I can feel it. I can feel it from across the screen that minds are being blown. Let's actually see what happens here when we do this. I will copy that code. I'm back in the interpreter. So what's going on here if I do something like this didn't work, right? So what went wrong here? Well, method missing got called, right? In fact, the debugger is helpfully telling us that where things went sour is in method missing. And here's my method missing that I defined, and here's the problem right here, right? We don't have a key in our currencies array for pound, so that fails. And when that fails, what happens? Then I try to basically punt up to my superclass, right? As in all object-oriented languages, there's the idea that if you don't have a function, but your superclass or one of your ancestor classes does have it, it gets control. Well, Ruby has the same thing, with the difference that method missing is called first. So before my ancestor gets a chance to handle it, I get a chance to handle it using method missing. So this is a nice extensible way to do the thing that we were trying to do before. Get it? Dry? So, what does this mean? Reflection and meta programming are not just these fancy big concepts, right? You can ask Ruby objects questions about themselves at runtime. For example, method missing gets to look at the name of the method that would have been called and the arguments that that method would have received. We can use that information to generate new code at runtime. That's what after underscore accessor is exactly doing, right? It's creating on the fly getters and setters for instance variables, which means you can have code that writes code. And as we just saw, you can reopen any class, whether it's your own or whether it's one of Ruby's built-in classes, at any time, and you can add stuff to it. You can modify what it does. Now, one of the things about Ruby that when I first explain this to people who come from another language, one reaction that is very common is, oh my gosh, that's chaos. You can reopen any class, and if I'm working with somebody's code, I don't really know if a string is a string or if it's a special kind of string. And if I call a method and they've got all kinds of method missing hooks, then I'm really not calling the method I thought I was called. That's chaos. So here's my message to you. You're all grown-ups. At least I assume most of you are grown-ups. And with great power comes great responsibility, right? Any language that gives you enough rope to hang yourself demands that you have a certain amount of taste and when it's good to do this. If in doubt, you can ask somebody who's more experienced. You can look at other people's code. And it's true that there are some abuses of these features, as there are with any good features. So any good technology can be used for good or evil purposes. We will try to present examples of good purposes that lead to beautiful code, but things like code review, pair programming, and so on are going to help us avoid some of the worst excesses that will lead to poor uses and or abuses of these features.
Yeah, so what I'm doing there is in the background trying to, so, this is partly, I'm checking, getting my head into the space of what the videos are on this week that I'm about to release, making sure that they play in the browser and so on. And in the background, I'm setting up, to sort of loop through here and update all of the HTML elements to point to the correct chat, which is a sort of a tedious operation. But I think we found that the fastest way to do it is to open a whole series of little windows like this, and then yeah, I'm going to do that. Control A, Control Paste. Is that even? Yeah, no, I am updating it. We don't need those spaces particularly, but anyway, okay. But so, right. So if we've got this issue, we're going to go to do a multiple choice question. The video doesn't break in the right place, but we don't have fixed videos from Adriel, so I'm just not going to worry about that. And so we've got this question: suppose you want to handle $5 in rupees. Was a bit changed to numeric to support this. So $5, it should be, and I always get these wrong way around. I think we could do method missing. We don't have to. This is the class method. This is the instance method. Isn't that the right one? Yes. Okay. Right, and that's part of me checking that the quizzes are doing what I think they're doing, which I failed to do last week because of kind of chaos and explosion with releasing, having to back out of Adriel's video edits in week 1.
So with that in mind, let's extend that example and say, now we want to do this. We want to be able to write €5 in rupees, or in some other currency of our choice. So as a general approach, what would we want to do in order to make this happen? One possibility is we could say we could change numeric method missing, and we could detect calls to in and take over the arguments. That would be one way. Or, so that's numeric method missing, that's the class method. Or we could change the instance method, numeric method missing, to do that same thing. We could define a new method called in as an instance method of numeric. And by the way, by now you are getting used to the notation that numeric.method missing means method missing is a class method. Numeric hash method missing means it's an instance method. That's just Ruby notational convention. Or we could define a class method, numeric in. So which of these 4 is likely to be the most appropriate way to handle this kind of example? Let's take a vote. Voting. Finally, I have a question that has caused some controversy. So talk about this for a minute. Okay, let's start taking another vote. Ready, everybody? Ready, and voting time. Voting time. Okay, far from it. There's red and blue have some support. Actually, I think almost every choice has some level of support. So let's see what's going on here. This is a good one to talk through. Okay, so let's go through these choices. First of all, just by the fact that when we call 5.euros, what kind of a method is euros? Instance or class? It's an instance method, right? We're calling it an instance of fixnum. And remember how we defined the method? All it does is multiply the number by something. So what kind of thing do we get back from the euros method? Also a fixnum, okay? So if we want to be able to call in rupees, for example, on the result of this, in is also going to have to at some level be an instance method, right? That much we can agree on. So answers that are defining any kind of class method probably are working up the wrong tree here. What about, okay, so not class method, but what about this? What about modifying the method missing like we did before? That was defined in an instance method, right? It gets called if an instance of the object is unable to respond to something. So could we augment method missing to handle calls to in? Yes, we could. Is it a good idea? Not necessarily, right? Because in the previous example, the motivation for things like doing currencies is it gives us a general way to handle a lot of different method calls that really all do the same thing. They just multiply something by a number. So it's much more compact. Instead of defining 20 methods for 20 different currencies, we just use method missing to handle it in a much more compact way. But this is a much simpler thing we're trying to do. We're just trying to define one new method called in that is essentially fixed sum and will cause the conversion to happen in ways that we haven't determined yet. So defining an instance method called in is the simplest solution to this problem. The method missing solution would work, but it would be like killing ants with a sledgehammer. You don't need metaprogramming to solve this problem. This is just a plain old function call. So part of the reason to have this exercise in here is, again, just because you have these powerful mechanisms available doesn't mean you always have to use them. In fact, you should do the simplest thing that could possibly work. Remember, that's one of the mottos of extreme programming. And in this case, a plain old instance method will do absolutely fine. Any questions about that before we move on?
Okay, so we can now. I'll have to click on that one. I mean, what's ironic here is that edX has just they've just added handouts element to their videos. So anyway, so here this is we're dealing with a chat element. Something else that we had to go through was put previously we had to put like HTML blocks with links to all of the slides. Here we could now move these to be in the video as a handout element, but you know we've got that's actually would generate a lot of work. I mean, it doesn't now that we have a lecture slide link in all the places. I guess until the lecture slides update, it doesn't seem to make much sense to do that. So I think I've now got at least all of these. I will remove the old discussion forum links, which will no longer work, I think, or at least point to the wrong discussion forum. And we've got the live chat pointing to the correct location, so I can now go through all the sections in here. And I need to get them all to the top, so I can do it in as a robotic a fashion as possible. I should start the 3.6 blocks, iterators, functional idioms. I guess we've also got a question about whether these.
Our next topic is one of the areas that at the same time one of the most powerful things about Ruby, and also one of the things that people new to the language get a little tripped up on because they're features that are not nearly as common in other modern languages that most people are using. Certainly not so in Java, a little bit in Python, but even there not so much. So let's talk about blocks and iterators and some of the functional idioms that they enable. Functional programming, if you have the good fortune to take a course that no longer really exists here called Structured Interpretation of Computer Programs, it used to be taught in a language called Steam. And that course, among other things, had an introduction to a really deep idea called functional programming that has been in the language community for a long time, and some people, including me, think it doesn't always get the airplay that it should. And what we're going to talk about in the next few minutes here is how can techniques from functional programming actually help us rethink some pretty basic programming concepts, like, for example, iteration, something we do so often we take for granted. We do for loops, we traverse data structures, and more importantly, why should we care? Why is it worth rethinking our approaches to some of these pretty fundamental programming constructs? So let's just start out with some examples, and as usual, you'll get used to seeing the examples, and you'll quickly come to realize, as you use the language more, why these are valuable things that you can do. Here's a collection of three things. An apple, a banana, and cherry. It's just an array of three strings, and I can say, with each string, just print it. So that looks like a loop, right? The tendency, if you come from an imperative language like Java, is to say, oh, I get it. That's like a way of writing a for loop over the array elements. It's not. Take it on its own merits. It's each. Here's a collection, and with each element of the collection, do something. Let's do a couple more examples to drive that home. You could do this, but that's really just syntactic sugar for something that's more like this. Right? What's going on here? What is this up to business? Well, we know it's a method call. We know it's a method call on an integer. We know it's a method call that takes one argument, and it can be followed by a block. A block is just a lambda expression. It's a procedure that has no name. In this case, it's a procedure of one argument, num, and what it does is just print out that num. But really, that's what it is. It's a procedure. It's a function call. And what I'm really saying is, I'm going to generate a list of numbers, and for each one of them, I'm going to call a function passing that one thing as an argument. Here's another shortcut that Ruby provides. Rah, rah, rah. I've also, in this case, substituted braces for do and end. Less common in an idiom, but sometimes you'll see it. So, don't be too confused. Whoops. There we go. Sorry about that. Don't be confused if you see the idiom of substituting braces as opposed to substituting braces for do end. So what's going on in all these other examples? I mentioned this briefly in a previous lecture, but what all these examples have in common is that we're allowing the objects to manage their own traversal. So in this case, we have a range of objects, the integers 1 through 10, and we're saying traverse yourself, and for each element that you give me back in the traversal, I'm going to provide a function that you call with that element as an argument, an anonymous function, an anonymous lambda expression. Your friends will be really impressed if you use that word regularly in conversation. They'll also stop inviting you to parties, but whatever. So that's an example of range traversal. Well, what about this thing with arrays? Well, we saw that we could take an array and say for each element in the array, again, I'm going to give you a function, and you're going to call that function with each of the array elements. So what's interesting between these is that you have no idea as a programmer internally what mechanism is being used to grab each element and provide it to you. You're giving that responsibility over to the target. You can do a similar thing with hashes. Remember that hashes have keys and values, so there's actually a couple of different constructs provided for going through the key value pairs. You can say for each key, give me that key and do something, or you could say for each key value pair, because the anonymous function can take more than one argument. It could take 0 arguments, in fact. And again, the simple example I gave before, 10.times, well, that's really just a shorthand for something like this, right? Except that it's an iterator of arity 0, it takes no arguments, because if you're saying 10 times, presumably you don't care about the value of the index. If you cared about the value of the index, you would do something like one of these first cases. So what this leads to is something that a lot of Ruby programmers call expression orientation. You don't think in terms of, I'm going to do something to this collection. Instead, you think in terms of, hey, collection, I'm going to ask you for things, and I'm going to do things to your elements. So for example, I can collection X is just an array of strings, and I can say, sort yourself. I can say, take your unique element, which, by the way, what does that do? It returns a new copy. So X is not being modified here. No X's have been harmed in the preparation of any of these examples. I'm getting a new copy, which is X with the replicated elements removed, and then I'm going to reverse that. So I get banana, cherry, apple. There are versions of some of these that are dangerous. Remember I said that sometimes you can see a function name that ends with bang, and this function is dangerous, or it may have side effects, so use with care. So in some cases, like reverse, there's a variant that ends in bang that does modify the receiver. So x reverse bang, or x reverse actually means x will be modified. There's also map. If you use language like Python or even Scheme, map is for each element of the array, I'm going to do something to each element, and the result is to return a new thing. So whereas the result, before we were traversing the elements, we're just saying, here's a function call, and it's going to do something with each element. Map goes further and says, actually, the result of the overall map is a new collection in which each element has been, in which each element is the result of calling that via the anonymous lambda. So slow. In this example, I take my original collection of fruits, and for each element in the collection, I'm going to call reverse, which reverses a string, returns a new copy of the string with the element reverse. So the result of this intermediate step is just an array in which each of the words has been individually reversed. Oh, and by the way, since the result of the overall map is itself a new collection, I can call sort on that. So what you'll see in Ruby is you'll see A.B.C.D. You sort of build up a list of things you want to do. It's almost like a Unix pipeline. But the idea that everything returns a copy of something, has a value, the value is an expression, and then you can continue to do more things on that expression. That way of thinking really comes from functional programming. And we're going to see some cases where it's very, very useful. Here's another one that Ruby provides, collect, which says, give me every element of your collection, and I'm going to collect all the elements for which this function returns a true value. Right? And one thing that you can test for is whether a string includes a character. You can test whether an array includes a character. And in a moment, we'll talk about why things like include seem to work all over the place with many different classes. I can ask, is it the case that any of these elements satisfies a particular condition? There's a real-life example that I would suggest you check out offline because I don't want to take time to walk through in this video, but just to give you a preview of it. I'll just show you the code. We're not going to walk through in depth right now. Anybody have a Clipper card who lives in the Bay Area? It's your public transit card, and you can check your balance online and things like that. And I wanted to write a script that would basically let me go to a single URL and check my balance without having to log into their website, which I'm not a huge fan of. So I used a library called Mechanize, which lets you write scripts against a remote web server. And I created a new Mechanize object. I post to the URL of the Clipper site with my username and password. And notice the dot at the end of every one of these lines. This is all one line. Right? Remember I said A.B.C. I'm calling a variety of different methods to build up this expression. So I'm posting a form. The result of posting a form is whatever the site sends back. Then I'm going to look for a link that has this href. Click on that link, parse the resulting page, looking for these HTML elements, go to the first row of the table, go to the second, third column, and look for content that matches a $ followed by decimal amount, and return HTML. That's one statement, kids. Okay? Now, I'm not saying that was beautiful code. Don't get me wrong. I need something quick and dirty that would work. But the fact that I was able to write that in such a compact way is really what I'm talking about.
Okay, so edX being very slow. I think at least this week we're not going to have loads more. There's not such a large number of videos this week. Looking at intro to PDD and TDD, I've opened some of them. Others are being slow. I guess here I want to, what do I want to do? I want to reload this and see that I've updated all the more Ruby things to be the right sets. At least the course outline is reloaded there. Rails intro, that's a long one. Okay, yeah, ESaaS chapter 3.5, 3.6, 3.7, 3.8. I guess I see sensibly what I should also be doing there. Well, look, is 8.1, 8.2 overview of BDD and TDD. 8.2 getting started with RSpec. I guess that's the same. Let me get my copy of the physical textbook and check. Yes, that looks about right. Or at least approximately right. This is not completely off base. But so I guess, see, what I also want to be doing is finding, I guess, reviewing this chapter on Ruby, and then I guess it does look a bit better now, the text. It's still missing lots of space that I think it should have. What does that do? I don't know. Columns. But I don't know that I feel like I have time to review the textbook in great detail here, apart from just to check that the appropriate chapters are there. Right. Okay. So I guess I'm tempted to hit those off again. Now we've got multiple choice. So which string will not appear in the result of, I guess, in the background there, was I waiting for Armando to finish talking or the stuff to happen? I'm kind of checking on the IRC chat. guess I should be putting, I don't know if anybody's, all the Skype bridges are down. Could be good to put those into conference mode in case any student is asking for help in those areas. So we heard Tia is talking to students in the chat there. Oh, hey, Michael. How's it going?
Good.
Yeah, cool. I'm just mooking, as you might expect.
What does that really mean?
What does it mean? Well, I'm going through all the course materials ready for release.
You're reviewing them.
Yeah, well, and also that there's a series of minor changes that have to be. I mean, updating them to all use the new chat script, avoid having links to the old discussion.
Right.
And yeah, making sure that the book chapter references are up to date with the new version of the book. I guess I've missed. I've missed out. Yeah, annoying, and then of course like studio crashes from time to time. And some people were. We've got this now. We've got this, I don't know, pro tips from Aaron Patterson thing, which is a new thing from Armando, which I guess I should make public because the TA is complaining. I guess Armando, if Armando added some formatting there, I think he must have done. Right. So we'll just add a chat box to there. This is an interesting area. Look, have you seen this before? Source location of unknown method.
No.
Yeah, that looks like that. That would be handy. Okay, so I've done that one is. Now I'm going to say something more sensible. Okay, so that's this. It's set to release right, and I make sure that I'm releasing the right stuff. Oh, okay, so I think those are all set. I'm continuing to work through this, which string will not appear in the result of. So I think this one. No, what am I doing wrong? It's it's that one because it's matching it with an A. Okay, right. Listen to the video.
So, here's an example for you to try. Which string will not appear as a result of running this code? And that's assuming the code runs at all. Perhaps the code has some kind of syntax error and won't actually run. Take a look at the code for a moment and think it over.
Okay, so I'm gonna.
By the way, match is a regular expression. Oh yeah, we got to do the first vote. I forgot. Vote. I think that's orange, right? Based on the lighting, most is that orange? Yes. Okay. Okay, well, since you guys are so quick, let's go talk through the answers here. What's happening in this code expression? We've got an array of 3 things, and when we call map, what is map going to do? It actually returns another collection, right? It's going to take this anonymous function, and it's going to apply it to each of the elements and return a new collection with those applications. So what's inside the function body? It takes an element and it calls reverse on it. We've seen that string.reverse will reverse a string, so what we're getting out of here is ananab, anana, isn't that cool? I picked a palindrome, and non, which is another palindrome. 3 great foods, by the way. The middle one means pineapple in Spanish. And so that's at this point, after the word end, that's where we are, right? We've got a new collection that has the 3 strings, but each one of them is reverse. And then within that collection, we're going to select, in other words, filter for all the ones that match a regular expression that says begins with A. So ananab and anana will fit that criterion. Non does not fit that criterion, so it will not appear, and therefore orange is the correct answer. And well done.
All right. So I'm going to try and. Well, that's it. I have this boring task of switching out, bulk editing all these pages, and so I kind of review the videos in the backgrounds. Go on to the next one.
Duck typing. This is fun. So I I keep saying, right, Ruby emphasizes what do you do, what methods do you respond to, instead of emphasizing what class are you. So the question is, why should you care about this, right? How does this encourage productivity? What kinds of reuse does it buy you? So an informal and humorous name some people have used to refer to Ruby's implementation of this is duck typing. And you may have heard the colloquial expression that if it looks like a duck, it walks like a duck, quacks like a duck, well, it might as well feel like a duck. So what we're saying is if you have an object that responds to certain kinds of methods, you just should treat it as the thing that it looks like it is. If it responds to things like give me each of yourself or reverse yourself, well, what is it meaningful to talk about those operations on? Well, it must be some kind of collection. So you say something quacks like a collection in Ruby, it means you can expect that thing to respond to most of the same collection-oriented methods that a normal collection, like a built-in collection arrays, would respond to. So if you use interfaces in Java, you'll notice that this is kind of similar, but I think this is actually much easier to use. Oops, sorry. So as an example, if I call sort on my list, what does that actually mean? Well, suppose my list is something like this array of integers. You can imagine what it would mean for sort to operate on that. What it was a list of strings. You can imagine what it means for sort to operate on that, or even a list of symbols, or even what you get back from IO read lines, which is all of the lines in a file one line at a time, right? This last one is basically saying sort this file. So why does this work? To get the answer to the question, we'll introduce one new Ruby construct that doesn't really appear in other languages. And in languages where it does appear, the term module doesn't mean the same thing. In Ruby, a module is a collection of methods that aren't a class. So you can't instantiate it. There are no instances of a module. It's really just a group of methods that collect a bunch of related behaviors and they go together. Now, in some simple cases, the use of a module is just to collect methods like methods related to a common set of operations, like mathematical operations or constants that are mathematical operations. That's pretty trivial. The much more interesting use of modules, which we focus on, is when you use a module to mix methods into a class. So what does that mean? Suppose that in my declaration for class A, I say include the name of some module. That means that when I try to call a method on an instance of A, if I call, for example, a.foo, first it will search whether class A has that method. Then it will search whether any modules included into the class have that method. And then it will do the other stuff we've already talked about. It will call a method missing. It will point out to the ancestors. But modules essentially give you a way to say, wait a minute, add a few things to this class. I'm not done with it yet. And the reason you want to do that is that it's often possible, because Ruby cares more about responding than it does about classes and types. It's possible to define modules, collections of behaviors, in a way that's reusable around a lot of different classes. So in fact, it might surprise you to learn, as one example, that the sort method we used on the previous slide as an example, you'd think that it's defined on arrays, but it's actually not defined on arrays. It's defined in a module called enumerable, and the enumerable module can be mixed into any class that knows how to enumerate the elements of itself. Let me say that again, because this is a little bit non-obvious, okay? We saw these different examples of using each, and I kept saying, we're not intrusively reaching into a collection and getting stuff. We are asking the collection nicely, please give me back each element of yourself in turn. I don't care how you get them, I just want each element so that I can do stuff to it. Now what we're saying is, well, if you can do that, then there's a bunch of things that I know how to do for free. For example, if you can return each element of yourself, I can sort you, right? Provided that your method, the things inside your collection are in fact sortable. We'll come back to that in a moment. What else can you do? If you can return every element of yourself, I can test every element against some condition. That was select and collect and those methods that we saw. So what does this mean? As a concrete example, it means that a mixin is like a contract. The module enumerable, we're going to use an example because it's used all over the place in Ruby. It's very common. It assumes that the target object and the class you're mixing it into know how to respond to each. Right? So like I said, if you define a new class, for example, a binary tree data structure, and you define each as a way to get at the elements of that data structure, you can now mix an enumerable and you'll get these methods for free. It will define for you predicates like all and any, collect, find, include, map, partition, a whole bunch of really neat stuff just because you agree to provide each. This is a hugely powerful behavior. Enumerable is also where sort happens to be defined in Ruby, but sort also has another requirement, which is that sort also has another requirement, which is that the class, the elements in the collection be able to respond to the spaceship operator. Remember the spaceship operator? It's kind of a rolling all the equality operators into one. A spaceship B is -1 if A is less than B, +1 if B is greater than A, -1 if A is less than B, +1 if A is greater than B, and 0 if they're equal, right? And you can imagine for whatever class you want, you can define the spaceship operator. You can define it to be sorting your colors in your favorite order if you wanted. Now, obviously, in classes like int and string, spaceship is already defined with the semantics that you would expect. But the important thing about this is, if you have a collection of things, and the collection responds to each, and if the elements in the collection respond to spaceship, then you have to do zero work to get that thing to be sorted, right? Because what is sorting? It's taking pairwise comparisons and seeing which one is greater of the two, and in some algorithmic form, putting those things back together. And in fact, there's another module which ships with Ruby called comparable, which says, if you provide the spaceship operator, which takes one argument, right? Spaceship takes one argument because there's the receiver of spaceship, and there's the thing you're comparing the receiver against. If you provide spaceship, then I will define these other ones for you. And I'll also give you happy ones like between, which tells you if one element is between two others according to sort order. So, what does this all mean? It means the class of objects really doesn't matter, almost at all. Only the methods to which they respond. Let's look at a couple of concrete examples of this. Sorting a file. Well, we have file by open. That's a method that returns an IO object representing an open file. And if you do IO objects actually define each, they define it as I'm going to return each line of the file in turn. That's pretty sensible semantics for reading a text file. So, what does that mean? I can say open a file and sort it. That's it. I don't have to provide anything because the thing that I'm calling sort on is a collection that responds to each and knows how to yield every element of itself. And inside that collection, what is each element? Well, it's a string, right? The line of a file. Strings know how to compare themselves. That's part of the built-in string behavior. So with no extra work, I can reuse behaviors despite the fact that the classes are different. I can also say which lines of this file begin with a vowel. Well, that's easy enough. We already know how to use select to pass an anonymous method to something, an anonymous function. So for every line of a file, we're going to pick out the ones where this regular expression match returns true. Again, zero additional work. We can do our own example with accounts, but before we do that, let's ask how it would be done.
I think quiz. I'm a bit.
Do you think you can listen to that any faster?
I would like to. I wish they provided ×3 and ×4. I don't have. I have limited time. It's a bit too slow for me. I don't know. I don't know why I can't just have a dial. So I would like to be able to just dial it up to whatever was the threshold of my ability to understand it, and that would be good. I don't know why I'm restricted to certain speed levels. I've got the quizzes. I'm going to have to review the quizzes more carefully. What is in quiz 2? What's this on? The first 4 weeks. Yeah, I think actually maybe I've got the date wrong about the release for quiz 2. Yeah, quiz 2 is okay. Quiz 2 should be released. Yeah, they should be shifted back one. I think my calendar there is slightly out of whack. So quiz 2 should be there. Oops. And so quiz, no, it's going to quiz. I want to move that off onto a different screen and I can't. Quiz 3 release, I have to edit. Oh, can I just add 1 week to it? Blah. So May 27th is going to be the 3rd of June. Okay. Is that right? Okay. Save that. So we've got quiz 2, then that one will need to go from the 29th to the 5th. Right, so 6, 5. 6, 5, okay. So, right, so we have a break from quizzes on the homework too, which is fair enough. And so quiz release and quiz 2. Right, yes, exactly. I've got it in there twice. Let's delete that. And then quiz 3 due. Okay, that's correct. So I think there was just an error there on the 2 and the okay. All right, that looks more like it. Okay. Okay, so I think I have now updated those to point to the right chapters. Yeah. Okay, so superficially, I've done all the bits. Oh, I should really check here is what are the release dates on this. So the homework, this is set to release on the 11th, which is the Sunday, and this is set to release on the 13th, which is the Tuesday. Okay, so I think that's right then. Okay, and I think it's time for me to break for lunch. I guess I'll just do this quiz. Well, what was this about? This is mixins and duck typing. What happens here? The result of ABC sort. Doesn't work. Saving as a variables. Can't compare them. Doesn't work, but would work if we defined. I think that's. If we have the savings operator, yes.
So if I define, here I've got 3 savings accounts that I've initialized with 3 different balances, and suppose I try to put those 3 savings accounts into an array and I try to call sort on that array. So what happens in this case? Does it work because the account balances are numbers and we know how to compare them? Does it not work? But if we added a comparison method, or if we passed a comparison method to the sort method, then it would work. Do we say it doesn't work, but it would work if we define the spaceship operator for savings accounts, or it doesnto work because since this isn't a basic Ruby type, there's no built-in way to compare them with the operator. So initial vote, I already see some cards even before I finish reading the question. All right, overwhelming votes for red. You guys are on fire today. Let's go through the answers here. Works because account balances get compared. Well, that's certainly what we would like to be the case, but comparing accounts isn't the same as comparing integers. That's not it. If we pass the comparison method to sort, that's not the Ruby way, right? The Ruby way is sort makes some assumptions about the thing you're trying to sort, in particular that the thing knows how to compare itself to other instances of that thing. So the correct answer is if we define the spaceship operator for savings accounts, and by the way, how would we define it? Well, an easy way would just be to say, as in this example, here's a way to define comparison on bank accounts. Here it is. It's coming out. We'll have 2 minutes left. Yes. So here's a way to define comparison on bank accounts. I'm lazy, so I'm just going to define spaceship, and then I'm going to include comparable to get the other ones for free. And in case you don't believe me, I will copy and paste that code. I already had the class account defined, so now, remember I had these accounts with high balances, and I can say, okay? True in so many ways. Okay, so what's the message here? Ruby provides a lot of useful functionality that already do the work you need to do. Your job, it's kind of almost very zen, right? You need to do the least amount of new work possible to get the functionality you need. When you have behaviors you want to reuse, you can put them into a module. That module can be mixed into many classes, as long as you make clear what does the module expect from the classes that you're mixing it into. If you want to reuse implementation, then you use the traditional thing. Classes have ancestry, they have subclasses, and as we'll see, contrary to what you might think coming from the Java world, remarkably often, what you want is the first one. You don't want to reuse implementation, you want to define behaviors and reuse them.
All right, I think I'm going to break for lunch there. Yeah. So I've been looking at quiz 2. I've been looking at these things. That's quiz 1. I guess over lunch I can watch the rest of the remaining videos and check where we are, and then I guess we need to get onto homework. Homework 1, sensibly. Goodness, right. Okay, that's MOOC.